Okay, over the course of the next couple days, we're going to talk about sums. Okay. Now you may be asking yourself, why do sums matter right now with integration? This will all come together, I promise. Okay. So first of all, sigma notation. This is the Greek letter sigma. You've seen it before. Okay. It means you need to add up a bunch of numbers, basically. Right? You worked with these sigmas when you did sequences in series. A series is the sum of a sequence, notated with this. Okay? Let's remind ourselves what each piece means in our series. Okay? So here's our sigma, that means sum, all right? You're going to have a value on underneath of the sigma and on top of the sigma, okay? Right now my function is in terms of k, so I'm going to have k equals n. This is telling me where we start our values. So this means start plugging in n, and then plug in the next integer, and then plug in the next integer. More times than not, you're going to see k equals 1, all right? But it could be anything. This just tells you what number you start plugging in, okay? Then you're going to keep plugging in consecutive integers until you get to this upper limit. This is where you stop. Okay? You're going to have a function inside of your sigma notation. This is what you're plugging values into. Okay? So what does this mean? Okay, if we have k equals 1 here and we have 5 up here, you plug in 1, and then you plug in 2, and then 3, and then 4, and then 5, and you have 5 numbers to add together. Right? Okay. Now, any letter can be used. Just make sure that whatever this letter is right here, it has to match the variable in here. All right. Most of the time, you're going to see I's, K's, and N's. All right. Okay. So this is what I just said. Okay. I said it in a more general way. But this variable down here is telling us what we need to plug in for. We should have a function in terms of that variable. You're going to keep plugging in numbers until you hit that top value. So let's do an example. K, so we have the sum from k equals 1 to 5 of k squared. What does that mean? Okay, plug in 1 to get 1 squared, plug in 2 to get 2 squared, all the way to 5, and what are we doing with them? So 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. What? Cool. Okay. Now I like this one. Here we have the sum from k equals 3 to 8 of 7. We do 7 plus 7 plus 7. How many times? 6 times. Because we plug in 3 and then 4, 5, 6, 7, 8. Okay, we're going to do these 3 summations. All right? So I'm going to let you do the first one. You're going to do the first one without me. Anybody have an answer for me? 66. Okay. Let's do the second one. We start by plugging in 2. What happens when we plug in 2? We get 2 times 4 minus 3. Plus, what do we get when we plug in 3? 2 times... Plus, when we plug in 4, this is where we're going to stop. 2 times 16 minus 3, we get what? Okay. I like this last one. You don't?
No, pi over 2.
Okay. Let's break it. Let's show our work here. When we plug in 1, we get 1 times the sine of, when we plug in 1 for k, this is pi over 2. Plus, when we plug in 2, we get 2 times the sine of 2 pi over 2, so we can write pi, plus 3 times the sine of 3 pi over 2. Remember our trig values. What is the sine of pi over 2?
1.
What is the sine of pi?
0.
What is the sine of 3 pi over 2?
-1.
Okay, we're going to go over some notation and some properties of these summations. Okay, so first of all, if I'm going to talk about a summation in general, okay, here I have the sum of a sequence, where b sub k is my sequence, right? And so if I talk about the sum in general, we start with our first term, and then we add our second term, and then our third term, all the way until we stop, in this case, at our nth term. Okay? Does everyone understand this notation I have going on here? Okay. Now, I'm going to go through some properties. You're going to kind of think that they're common sense anyway, which is good. Okay, but we need to talk about them because they're going to be important later with some more properties. Okay? So sigma notation. If you have a constant multiplied to your rule, okay, or your sequence, that constant can be moved outside the sigma notation, and you can apply it after you do the sum. Make sense? Okay. Also, if you have 2 terms added inside of your series, then you can break it apart into 2 series. You can do your summations separately. Huh? Okay. All right, and then the same thing with subtraction. These are the only 3 that we're going to worry about. Okay. This will be helpful to us, believe it or not, later when we do integration. More integration. Okay. So let's talk about these summations. Okay. Let's apply these properties to these summations. All right. Here, that 2 is going to be multiplied to every term, so let's just take it out and worry about the summation from k equals 1 to 3 of k, which means we have 2 times the sum of 1 plus 2 plus 3, which is? Okay. All right. And then here we can say, well, this is just the sum of k minus the sum from 1 to 4 of k squared. Okay, so we can think about these separately. The sum from 1 to 4 of k is just going to be 1 plus 2 plus 3 plus 4. Okay. And then we're going to subtract the sum of k squared. So 1 plus 4 plus 9 plus 16. Okay, so our 1's cancel, our 4's cancel, and we're left with what?
15. No. 20. Right? Yeah, 20.
Okay. Now, this could get tedious. Do you agree?
Yeah.
It could get very tedious. I have 3 shortcuts that I'm going to teach you and that you are going to remember. Okay? I don't know if you remember back in pre-calculus, but you did this unit where you proved by induction, mathematical induction, where you were given a series and you had to prove that that formula was true.
Yeah.
I'm not going to make you prove anything, but these are some of the formulas that you probably proved last year. Okay? So, here they are. I'm going to do a screen share. Okay. The first one is if you add up your terms from 1 to n of just the integers k, 1 plus 2 plus 3 plus 4, all the way to n. That is the same thing as taking n times n plus 1 over 2. Now, if you remember your shortcuts for arithmetic sequences, okay, if you're adding up an arithmetic sequence, you take the first and the last term and add them together, right? And so all of our sums are n plus 1, right? And then there's n over 2 pairs of the n plus 1 sum. Not important if you don't know what I'm talking about. Remember this formula. Okay? How about k squared? If we're adding up the sequence k squared from 1 to n, then we can say that is the same as n times n plus 1 times 2n plus 1 all over 6. Yeah, we have to start at 1.
Most of the problems only start at 1.
Yes.
No, we're going to start with 1. Okay, k equals 36.
And then some of you are still writing, but I'll go ahead and show this for people who are done writing. The sum from 1 to n of k cubed. N times n plus 1 over 2 squared. Do you think you can find these helpful?
Yes.
Probably, right? It's kind of annoying to plug in every single term and add them all together, correct?
Yes.
Hey, especially if we would have like 50. That'd be mean, right? Is anyone still writing these?
Now, K starts with 0. And we keep obviously do this because the 0 would just.
But just a little bit matter in this case.
So it starts with 0. So we just
For these three?
cool.
Okay, so let's practice. I have the sum from 1 to 23 of K.
Everybody using calculators?
No.
Of course.
I just taught you a shortcut. What's the shortcut for the sum of K?
23 times 24 is 2.
N times N plus 1 all over 2.
23 times.
So 23 times 24 all over 2. We basically have 23 times 12.
It's 230 times or plus 46, which is 276.
What is it?
276.
Look at mental math guy over there.
Yay!
And that didn't take you any more time than it would have to punch.
No, that was definitely at least a second longer.
Okay? But way better than saying 1 plus 2 plus 3 plus 4 plus 5 all the way to 23, right?
Unless you have
23 exclamation marks.
How about the sum from 1 to 7 of K squared? The sum from 1 to 7 of K squared. Well, we know our shortcut is N. What's N?
7,
Times N plus 1
8,
times 2N plus 1
15.
all over 6.
I don't know what the top numerator is.
Okay, well this is 2 times 3, right?
I
So
did better.
7 times 4 times 7. Right? So what is that? I just broke 6 up into 2 times 3. 2 goes into 8 4 times.
I didn't.
Helping you out here,
Just the
people.
way you did
How
that
did
was
they
weird.
get this?
I'm sure they did.
See, I would have found.
Okay? The sum from 1 to 6 of K cubed. Okay? Our K cubed shortcut is what?
4, 2, 2.
Okay.
7 or 6.
Hold on. N is
6,
times N plus 1
7.
all over 2. And then
Square it.
where?
21 squared. Well, it's something just over 400. Because
400.
20 squared is 400.
441.
That's baby Jared.
That's where my trick comes in handy, Aaron. There you go.
What trick?
You take, if there's like 2 consecutive numbers, you can square one and then you add the 2 consecutive numbers together. Then you add that to the square of the first one, it's always the square of the second one. So like, in this case,
Whoa!
K squared is 400, right?
Uh-huh.
20 and 21 are consecutive numbers. You add 20 and 21 is 41. Add it to 400, and that's the square of 21.
Ah, there you go.
That's like 6th grade math, guys.
I figured it out.
See, the way you described that,
Okay.
you just saw numbers.
Now what happens when I give you this?
We can't do a shortcut.
You distribute it.
Squared.
Can this be rewritten
You didn't tell us.
as K squared plus K?
And then you break it up.
Which means, using our properties, we can break it in up into the sum of K squared plus the sum of K. Okay?
Awesome.
So, let's K squared, what's that shortcut? N times N plus 1 times
61.
2N plus 1 all over 6.
Yep. 5 you can 5 times 31 plus 61.
Okay.
5 times 31 is 155. Then you multiply that by 61.
100 times 61.
Wait, what now?
100 times 61 is 610. 6,100. And then 50. That's 350.
It's funny seeing how we struggle.
That's 350.
Six times
3,500? Is that 3,500?
6 times 50 is.
Where are you getting the 6, bro?
Or 61 times 50 is.
Too much.
61 times 50 is 3,500.
It's 30 times 30. It's never mind.
30 times 31 is 900.
Yes.
Okay,
That's
times 61.
No, why'd you do that?
A lot.
I think we need to
Yeah. 5 times 31.
I just want somebody to find it.
5 times 31 is
On
155.
the calculator.
Do it on your paper.
So it's
9,455.
He did it on his calculator.
Cheater. Cheating! Jackson! You can't use your calculator on the test, bro.
When we sum up K,
It's a calculator then.
It's not gonna
N times N plus 1. Oh my goodness, you guys are driving me nuts. Stop talking. N times N plus 1 over 2.
310 plus 155 is 465.
Let's check these with our calculator. Okay. Get your calculator out. I want to remind you how to do these on your calculator. Okay, first of all, if you have a TI-84, you can press Math 0.
Yeah, but TI-83 can't, so
Nope.
we do.
So if you have a TI-83, you're going to go to second stat. You're going to go over to math, and you're going to press sum. And then you're going to go to second stat, go over to ops, and you're going to say sequence. Okay, now yours looks different than mine right now, right?
Yeah.
Okay. Do I have my 83?
So now we have to go and write it.
Okay, so do what I do. Are you ready? Our expression is k times k plus 1. So you're going to do the same thing as me. You're going to write x times x plus 1. Okay. Then put a comma in, and we need to define our variable, which is x, above 7. Okay. After you type in x, put comma. We want to start at 1. Comma, we want to end at 30. So yours should look like this. Right, TI-83s? Okay. That's how you check it with your calculator.
Wow.
How do you do it in the summation? Another one, the 84.
Just type it in like you see it. Except I would use x.
Click math and then 0.
So math 0.
Yeah,
It pops up and then you
And then I would
click
push x. Whoops.
mine says error
for the K,
Yeah.
use alpha.
Oh, you press up instead of later.
Yeah.
There we go.
Who's? Okay. Rainy, you got it under control?
Yeah.
Well, if you're talking about a sequence, comma, and no, the X, 1 to 30 are part of your sequence. Okay, so little vocab here. On the left we have closed form. On the right we have open form. Open form is, I mean, it's all of the terms written out, added together, right? Closed form is basically our shortcut. Okay? So you're going to be asked sometimes to write a series in closed form. Okay? So first of all, if I'm going to use our shortcuts, is this going to work? So we better rewrite this. Three plus k the quantity squared.
3 squared, and then plus the summation thing.
Well, let's just worry about this.
Oh, okay.
Plus 6k plus k squared. Right?
Right.
Okay.
I was.
I know what you're saying. Okay.
I was not sure.
So now we can break it apart, right? Notice how we're summing up to n. Up until now, we've been doing actual numeric values. Now we're just in general summing up in terms. So if I'm summing up the first n terms of 9, how can we write that?
9n, or 9.
9n. Why 9n? We're saying 9 plus 9 plus 9 plus 9n times. We have repeated addition, which is multiplication. Okay? What about 6k?
6
put the
is
6 on the other side and make it easier.
Okay.
and then you write n times n plus 1 over 2.
Mm-hmm. And then k squared?
N times n plus 1 times 2n plus 1 over 2. And that's it, you're done.
Mm-hmm. This is closed form. And use your shortcuts to rewrite it. Okay, without the summation. Questions? There's your homework.